In this video, we're going to learn how to solve quadratic trigonometric equations. Now, we've solved quadratic equations before, just involving a single variable, for example, x or y, whatever it may be. This time it's going to involve sin x or cos x or tan x, for instance. Okay. So we'll just have a look at the first example. So solve 3 sin squared x minus 4 sin x plus 1 equals 0. And we can see that this is a quadratic equation because we've got this square term here. Now we're solving, I should have said we're solving between 0 and 360. So we are working in degrees. So, like I said, we've got this quadratic equation. Now, we should know already that in order to solve a quadratic equation when it's equal to 0, that we need to factorise this, what is the left hand side here. So if we just go and do this, I'll do this on a separate slide and just do a wee bit of factorising revision here, just for anybody that needs it. So if we want to factorise this 3 sin squared x minus 4 sin x plus 1, I'm actually going to just use this as 3x squared minus 4x plus 1 because I'm sure most of you will be more familiar with that. So that expression here, I have substituted all of the sin x's here with an x, just to make the factorisation slightly easier on the eye, if you like, and then we'll substitute sin x back in at the end. So the way we learned how to factorise last year was using the area model, or you might have referred to it as the grid method. So firstly, we need to find the factors of 3, and that is the factors of the coefficient of the square term multiplied by the constant term, or the coefficient of the x to the power 0 term. So factors of 3 are 1 and 3, and -1 and -3. And you can see that we need these factors to add to give us -4, which is why I'm going to use this factor pair here. -1 add -3 is equal to -4. So that helps me within my area model here. So remember, we put in our square term and our constant term, and our x terms are made up using the factors of the 3 that we found. So instead of -1 and -3, it's actually -x and -3x. Now, we then need to find the highest common factor of this top row here. So the highest common factor of the top row is x. And then we need to find out x multiplied by what gives us 3x squared. And that is 3x. X multiplied by what gives us -x. That's -1. And then 3x multiplied by what gives us -3x, and that is -1. And we can do a wee checking method. -1 multiplied by -1 gives us +1. So we know that we've factorised correctly. So 3x squared minus 4x plus 1 is equal to 3x minus 1 multiplied by x minus 1. Now, remember, that's not actually what we were factorising in the first place. We were actually needing to factorise 3 sin squared x minus 4 sin x plus 1. That was the expression on the left-hand side of the original equation in the previous slide, in the question that we needed to factorise. That's what we needed. So we actually wanted that. So that factorised is 3 sin x minus 1 multiplied by sin x minus 1. You can see there I have replaced my x's again with sin x's because that's what they should have been originally. Okay. Right, so back to the question in hand then. So I was at this stage, I now have factorised that. So using the null factor theorem, we know that 3 sin x minus 1 is equal to 0 and sin x minus 1 is equal to 0. For the first equation, we can add 1 to both sides and then divide by 3, and that tells us that sin x is equal to a third. And the second equation, sin x is equal to 1 if we add the 1 to both sides of the equation. Now, We then, like before, need to take both of these equations separately. Okay, so for the first one, we've got sin x equal to a positive. So we know that our two answers are going to come from the first and second quadrants because that's where sin x, the graph of sin x, is positive. So one answer lies between 0 and 90, and one answer lies between 90 and 180. So inverse sine of 1/3 is 19.5 degrees. So that's our answer for the first quadrant. And the second quadrant, our answer is 160.5 degrees. Now for the second equation, sin x equals 1. This is one of those occasions where there's an exact value. So just now you should have alarm bells going off in your head thinking, right, what height? 1 is the height of the sine graph. What is the x value when the height is 1? So let's draw a quick sketch of the sine curve, and that is where the sine curve is at a height of 1, and we can see that that is at 90 on the x-axis. So that is one of our answers there, is 90. We've only got one answer coming from this equation as well, and that's okay, sometimes that happens. So possibly a lot of the questions you'll be undertaking, you'll get 4 answers, but if you don't be alarmed by that. It is possible to have less or more than 4 answers. So our answers in numerical order then, x equals 19.5, 90 and 160.5. And as always, I'm just going to refer back to the graph. So I'm going to plot this graph, 3 sine squared x minus 4 sine x plus 1 equals 0. It's quite an unusual graph. It's not something you're going to see all the time. It's certainly not something I would see all the time. And we are solving for when y is equal to 0. So that's basically where it cuts the x-axis. What are the roots here? Because that is where y is equal to 0. So we can see it cuts in 3 places. Now you can definitely see that 90 is one of our answers there. And you can see our first answer, about 19.5, that's roughly about correct. And 160.5, and that's roughly there as well. So we can see that it was 3 answers we were looking for between 0 and 360. So those are our final answers. So if you pause this before the screen goes blank and copy this down in your notes jotter.